we're going to be talking about expressing radicals. So a radical, hopefully some of this will be review for you, but if not, this is going to be a lot of fun. Okay, with radicals, we are mostly talking about square roots in Algebra 1. We will see some other things, but right now let's start with square roots. So a square root is one of a number's two equal factors. So we talked a lot about factors in our last section, and a factor is just one of two numbers or three numbers or whatever that multiplies up to another number. So in this case, we have two equal factors, which means they are the same thing, and the symbol for the square root is the radical sign. It looks a lot like the sign, but it's not. It's got that little check thing, okay? And that is the radical sign. The number under the radical sign is called the radicand. So if you look at our little example here, we have the square root of 9. Okay, our radicand is 9 because that is what is under the radical sign. And that is equal to plus or minus 3. So that's the only time in this section where I'm going to introduce that plus or minus 3, but that's just what that says, and we'll go into that another time. So mostly we're going to be dealing with the principal root. Now, the principal root just means that we're dealing with a positive square root. Okay, positive square root. If we want to know the negative option of the square root, then we will put a negative sign in front of that radical. Okay, so here I have negative square root of 25. That is equal to negative 5. Okay, that square root, it's important that the negative is outside of the square root. Okay, examples. So I really hope that you are ready. You have pencil and paper and you're ready to take notes. If you have my note packet, awesome. I hope you've been filling it out. So our first example, we're looking at two square roots. The first is the square root of 16. So what two equal numbers multiply up to 16? Hopefully you said it was 4. So 4 times 4 is 16, and we take the square root of that. It is just 4. So the square root is like the inverse operation of square. Okay, just like inverse operations, adding and subtracting, multiplying and dividing, they undo each other. The square root is undoing the square. Our second example is negative square root of 9. So that is pretty much exactly what we did. Well, not exactly, but close to what we did in the previous slide. And that means we were looking for a negative answer. And the square root of 9 is 3. So there we go. 3 times 3 is 9. We have that negative in front, and that makes it negative 3. Let's talk about roots. Okay, roots go below the ground, and it's important to remember that roots are on the bottom. Okay, a cube root is going to have that radical sign with the little 3 hanging out on top. You see that? It is one of a number's 3 equal factors. So actually, I just remembered I can do a little laser pointer. Here we go. So that's that 3 I was talking about. So if I were looking, okay, if I have here 3 cubed is equal to 27, that means the cube root of 27 is 3. Again, that is that inverse operation I was telling you about. An nth root, okay, n meaning any number, is one of a number's n equal factors. So if there's a 5 over here, then there are 5 equal factors. If there's a 6 over here, then there are 6 equal factors, and so on and so forth. So here we have a 4th root, which means there are 4 equal factors that multiply up to this 16. So here we have 2 times 2 times 2 times 2. So we have 2 times 2, that's 4. 4 times 2 is 8, and 8 times 2 is 16. So that does multiply up to 16, and they are 4 equal terms. We take that 4th root, and that's 2. Let's do some practice. So I'm going to show you the first problem, and I really hope that you can pause the video for a minute or two so you can try solving this on your own and then replay it to get the answer. Hopefully you were able to see that the cube root of 125 is 5. Okay, we have 5 times 5 times 5. That's 3 5s. Great. I only need 1 to come out of my radical sign. So again, here's my inverse operations. These two cancel, and I'm left with 5. Here's another one where you can pause the video and write in your notes, try this on your own, and then play back when you're ready for the answer. So we're looking at 4 equal numbers that multiply up to 81. In this case, it is 3. And so I know a lot of you guys are going to have these memorized, which with cube roots and fourth roots, that can be kind of hard. So what I do is just trial. So I do 2 times 2 times 2 times 2. I'll do that 4 times. If that's 81, nope. Try 3. Okay, so that is a quick and easy way. Okay, maybe not quick, but it's a simple way to figure out what the roots are. Negative radicands. Okay. An even root of a negative number is not a real number. Let me say that again. The even root of a negative number is not a real number. So even roots means square root, fourth root, sixth root, eighth root, even numbers, okay? Let's see why. 4 times 4 is 16. Okay, those are 2 equal numbers that equals 16. Negative 4 times negative 4, those are 2 equal numbers, also equal 16. Well, what equals negative 16? A positive 4 and a negative 4. But those aren't 2 equal factors. That is why the square root of negative 16 is not a real number. However, the odd root of a negative number is a negative real number. And I spelled number wrong. I totally forgot to fix it. Oh well. We have the 5th root of negative 32. And if we think about this, and we have the little 5 right here, negative 2 to the 5th power, we know that there are going to be 5 negative numbers, and we know when we multiply 2 negative numbers, they're positive. Okay, so out of our 5 numbers, these 2 become positive, these 2 become positive, and then we're left with Mr. Negative over there. So that is just that inverse operation that we are talking about, and that is why we have a negative number. Estimating irrational numbers. So here we're not going to be looking at perfect numbers. You can check your answers on a calculator. This is just estimating. It helps if you have perfect squares memorized. I suggest up to 400. That will get things going a lot quicker for you, and it's really not that complicated. Most of you guys have up to 12 memorized, and then it's just 13 times 13, 14 times 14, and all the way up to 20. Let's take a look at this example of the square root of 8. My first step is I want to find a perfect square, okay? A perfect square that comes before the number in the radicand. So the number under my radicand is 8, and I'm looking for a perfect square that comes right before 8. So my perfect squares, I have 1 times 1, that's 1, 2 times 2, that's 4, 3 times 3, that's, the one that comes before 8 is 4. Okay, let's look at our next step is to find the closest perfect square that comes after the number in the radicand. So that number again was 8 under the radicand. I'm looking for the perfect square that comes after that, which is 3 times 3, 9. Now we're going to set this up as an inequality and take the square root of each number. So I have the square root of 4 is less than the square root of 8. which is less than the square root of 9. Now I'm going to simplify because I know what the square root of 4 and 9 are. So the square root of 8 is somewhere between 2 and 3. If you see right here, I'm looking at my radicands again, 8 is closer to 9 than it is to 4. So that's showing me that the square root of 8 is going to be closer to 3 than it is to 2. Okay, here's another chance where you can pause the video and try these out on your own and play when you are ready to see the answers. We're going to estimate the square root of 130. So again, our first step is to find that perfect square that comes before 130 and the perfect square that comes right after 130. In this case, I have 121 and 144. My next step is, and that's an error, I should not have that square root should not be there right now. I got a little radical happy, I guess. You're going to take the square root of each number. The square root of 121 is 11 and 144 is 12. Hopefully those are memorized for you guys. So the square root of 130 is somewhere between 11 and 12. Okay, our next example, we have a cube root. Do not freak out. It's okay. You can do cubes. I know you can. You totally do it. I promise. Same steps. Okay, this time we are looking at the perfect cube that comes right before 52 and the perfect cube that comes right after 52. Okay, what is going to be right before 52? Well, let's check out our numbers. 1 cubed is 1. 2 cubed is 2 times 2 times 2, that's 8. Then 3 cubed is 3 times 3, 9. 9 times 3, 27. And then 4 cubed is 4 times 4, 16. 16 times 4 is bigger than 52. So it looks like the perfect cube before 52 is going to be 27. And the one right after is going to be 64. So I'm setting up our inequality again. And I'm going to take the cube root of each number. I know what the cube root of 27 is, and I know what the cube root of 64. So I'm going to write that out. So I have 3 is less than the cube root of 52, which is less than 4. And if I look over here at my numbers again, I see that 52 looks closer to 64 than 27. So this is going to be 3 point something closer to 4. Okay, roots and powers. Remember how I told you that roots go on the bottom? This is where you're going to need that. We are going to convert between radicals and exponential expressions. It's okay, you got it, and I totally believe you can do it. So we're going to start with this awesome little formula thing. Okay, the exponential expression x to the a over b power is equal to, you see here, this is my root, right? The b root of a, x to the a power. So a is on top, a is the exponent, b is on the bottom, b is the root. Roots go on the bottom, right? Let's put this into action. We're going to look at rad 4, and I'm sorry, I tend to call it that, the square root of 4 times the square root of 4 in 3 different ways, just so you can see how we can solve the same thing in different ways. So the square root of 4 times the square root of 4, we have the square root of 4 is 2, that square root of 4 is also 2, so 2 times 2 is 4. Easy, right? Well, we're going to practice doing it this way, so that way when we see other numbers or variables, you don't freak out, because this is the same process, okay? If I'm following this rule, okay, my 2, this is to the second root, right? But we don't call it the second root, we just say the square root. And then I have the invisible 1 here with my 4. So I'm going to rewrite this as 4 to the 1/2 power. Okay, 1/2 just means the square root of. So 4 to the 1/2 power times 4 to the 1/2 power. Well, according to our exponential rules, our properties, okay, if they have the same base, we can add the exponent. So that's what we're going to do here. We have 4 to the 1/2 plus 1/2 power. 1/2 plus 1/2 is equal to 1. Okay, so 4 to the first power is just equal to 4. Hopefully you guys still remember that. The next way I can write this is the square root of 4 squared. And like I told you about these inverse operations, we can cancel these. It can happen. So we can cancel these. We can rewrite this as 4 to the 1/2 power, and the power to the power rule, that's one of our exponential properties. We multiply our exponents here. 2 times 1/2 is just 1. 4 to the first power is 4. Okay. Let's do some practice. Again, I recommend that you pause the video and start it when you're ready to go. Let's convert 5 to the 2/3 power to radical form. First of all, what is my root? Which number in that exponent right over here represents my root? Hopefully you said 3. So 3 is my root, which means 2 is my power. And when I rewrite that, I'm going to keep my base of 5. So I have my radical sign that I wrote 5. I wrote my 3 over here because that is my root, and here's my power. Okay, now let's do the opposite. Now I have the 5th root of x cubed. Where is my root? Oh, totally forgot about that. You can simplify that, right? So 5 squared is just 25. Had to do that. Okay, so the 5th root, that is my root. It is going to be on the bottom when I rewrite this. And then here's my power. That's what's going to be on top when I write my exponent. My base stays the same. My base was x. And then I rewrote this with 3 on top because that's my power. And root on the bottom. Okay, so there's more practice in your books. And then of course you just go on Excel to do the rest of your practice. Thanks for listening to this video, and I hope you have a very blessed day.